Hi, welcome to lesson 15C, the product rule. Today's goal is to differentiate products of functions. So we've seen in the past, if we have some sort of addition of functions or a subtraction, so an addition or a subtraction of functions, we know that the derivative function or the gradient function is just the sum or difference of those derivatives, of each of those different the different functions that are being added or subtracted together. So let's take a look about products of functions now. So if we take a look at f of x, and that's equal to u of x multiplied by v of x, we want to know if, the big if, f prime of x is going to equal u prime of x multiplied by v prime of x. Much in the same way that f prime of x equals u prime of x plus or minus v prime of x when the original function is the sum or difference of two functions. Okay, so just for an example, let's take a look at this here. Let's say that f of x equals 100 x to the power of 5. And so then let's break this apart and let's say that u of x is, say, 20x cubed, and then that means that v of x would be 5x squared. Okay, because the product of these will give you this. So f of x is u of x multiplied by v of x, which is 20x cubed times 5x squared, and over here I'll have f of x equal to 100x to the power of 5. So then if I take the derivatives now, f prime of x is equal to, well, if we do this the way we're hoping to see, or wondering if it'll be, the result would turn out to be this way, we'll take the derivative of this, so we bring the 3 down in front, multiply by the 20, we get 60x squared, and then we multiply the 2 down in front here, multiply by 10x. So that's going to give us then 600x cubed. So if we go over here to the original function, the actual function itself, f prime of x, we bring the 5 down in front, multiply by the 100, so we get 500 x to the power of 4. Okay, so this shows us that f prime of x does not equal u prime of x multiplied by v prime of x. But somewhere along the line, some brilliant mathematician came up with the product rule of differentiating. And so if we have f of x, again u of x multiplied by v of x, then the actual power rule states that f prime of x equals u prime of x multiplied by v of x plus u of x multiplied by v prime of x. So this is the power rule, the product rule. So f prime of x equals the derivative of the first function multiplied by the second plus the first function multiplied by the derivative of the second. And if we also, just a different form of it, if we know y equals u times x using Leibniz notation, then dy by dx is going to equal du by dx multiplied by v plus u multiplied by dv by dx. Just as a different form for you. Okay, which is the same sort of thing, the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. And actually, now that I look back at this should be v, not x. Okay, so let's take a look at a couple examples now. let's take a look at the function f of x being negative x cubed multiplied by 3x to the power 4 minus 2. Okay, so here's our u of x, negative x cubed, and here's our v of x, 3x to the power 4 minus 2. So if we use the product rule, we get f prime of x. So you take the derivative of the first, which is negative 3x squared, multiply by the second, we just leave that alone, and then we're going to add the first multiplied by the derivative of the second. Okay, and then once we do that, we can just simplify this a little bit. So what it'll do now, this is the derivative is complete at this point. Now the rest of it would just be some algebra and simplification. So we'll multiply negative 3x squared in through this bracket and negative x cubed into this. So we get negative 9x to the power 4 plus 6x squared, and we'll multiply these two together. Sorry, this is x to the power 6, and then we multiply these together and get negative 12x to the power 6. And we group things together, so we get negative 21x to the power 6 plus 6x squared. Okay, so you may be thinking, well, this is pretty simple, straightforward function, and this isn't too complicated. So what if we're, instead of doing the product rule, it seems like a lot of work, why don't we expand this in and take the derivative of that? So let's take a look at that. Let's take the same function, negative x cubed multiplied by 3x to the power 4 minus 2. We'll expand this in first, and then we'll take the derivative and see what happens. So we get negative 3x to the power 7 plus 2x cubed. Okay, seems pretty simple. And then we take the derivative, so we get negative 21x to the power 6 plus 6x squared. So we notice that, of course, these two functions, the derivatives are exactly the same because they came from the same original function. The second method was just by multiplying the two functions together and then taking the derivative. So it looks like it's a lot less work in this case, and that's very true. Where we won't be able to do this as easily is if we have more complicated functions to begin with. Okay, so let's look at, say, y equals x to the power 4 plus 3 multiplied by negative 4x to the power 5 plus 5x to the power 4 plus 5. So yes, you could use the distributive property and expand all this in and simplify it all and then take the derivative. But in this particular case, and cases like this where the two functions are more complicated than the original two that we use up here, we'll find that the product rule is actually going to be easier, less work than than just expanding it out and taking the derivative. So we'll take the derivative now. So we take the derivative of the first, so it's 4x cubed, and we multiply that by the second, negative 4x to the power 5 plus 5x to the power 4 plus 5. We just leave that alone, and then we add the first, leave that one alone, and then we take the derivative of the second here. Negative 20x to the power 4 plus 20x cubed. Okay, so the derivative is now finished. That's the gradient function right there. And again, I mean, we can make it more complicated now by multiplying it all together, etc. In the future, what we will probably be doing is we'll be doing some factoring because we're going to be getting into graphing. Now, because this is like a higher order type of function, we would probably have to simplify it all. We'd have to do this thing called the factor theorem to then start finding zeros and roots and whatever. So we're just going to leave this as it is right now. But in the future, when we start getting into graphing, we're going to be doing some factoring of these things as well. Okay, but that is the derivative, and that is the product rule. So we'll look at a few more examples tomorrow in class, but in the meantime, please take a look at example 7 on page 368, and then peruse through exercises 1 through 5 on page 369, just to kind of whet your appetite for tomorrow's main course. So thanks for watching, and we'll see you in class.